Hello and welcome to Crop Science 6049. In today's lesson, we are going to look at transpiration in plants. By the end of this lesson, you must be able to describe what transpiration is and also describe the environmental factors affecting the rate of transpiration. What is transpiration? Transpiration is the process by which water vapor is lost from the mesophyll cells surrounding the sub-stomatal airspace inside the leaf to the outside atmosphere via stomata and lenticels. Let's take a look at the factors affecting transpiration. First, we are going to look at relative humidity. Relative humidity is the amount of water vapor in the air compared to the amount of water vapor that air could hold at a given temperature. A hydrated leaf would have relative humidity near 100%, just as the atmosphere on a rainy day would have. Any reduction in water in the atmosphere creates a gradient for water to move from the leaf to the atmosphere. The lower the relative humidity, the less moist the atmosphere, and thus the greater the rate of transpiration. When relative humidity is high, the atmosphere contains more moisture, reducing the rate of transpiration. The next factor is temperature. Temperature greatly influences the rate of transpiration in plants. As temperature increases, the water holding capacity of air increases sharply. Because warmer air can hold more water, its relative humidity is less than the air sample at lower temperature. Because cooler air holds less water, its relative humidity increases. Therefore, warmer air will increase the rate of transpiration and the cooler air will decrease the rate of transpiration. The next factor that we are going to look at is light. Light has a controlling effect on the opening of the stomata, through which water primarily escapes in gaseous state. In general, transpiration rate is high during daytime, particularly when light is bright, than during nighttime. The stomata are typically open during daytime, allowing the entry of carbon dioxide and the exit of oxygen. The opening of the stomata enables the escaping of water as water vapor in the process of stomatal transpiration. The next factor that we are going to look at is soil water. Plants with adequate soil moisture will normally transpire at high rates because the soil provides the water to move through the plant. When the supply of water from the soil is limiting, the rate of transpiration tends to slow down. This is more pronounced where other conditions such as bright light and warm temperatures favor escape of water from the plant. In this case, water deficit within the plant may occur, leading to the closing of the stomata because the leaf has lost turgor or firmness, which is manifested by wilting of leaves, because the water in the xylem that moves out through the leaves is not being replaced by the soil water. The last factor that I'm going to look at today is wind. This environmental factor affects transpiration by removing that thin moist layer of air called the boundary layer, which lies next to the surface of the leaf. This moist air causes a lesser water potential gradient from the leaf, resulting in a reduced rate of transpiration. This layer also reduces light penetration into the leaf. But with wind, this boundary layer is replaced with drier air, thus increasing water potential gradient and enhancing transpiration. However, strong winds may cause excessive loss of water from the leaves, leading to the stomatal closure. Thank you for watching. Don't forget to subscribe to this channel. If you have any questions, additions and subtractions, please write them in the comment section. If you have benefited from this lesson, click the like button.